Looking at number 5, we have to find the value of each variable and write them as simplified roots. So if I look at my right triangle, I notice that I'm not given at least two sides, only the 11 root 3, so I can't use Pythagorean theorem. But I do see that there is a 60-degree angle. Therefore, I could use my special right triangles, the 30, 60, 90. This is 30 degrees here using the triangle sum theorem. So I like to use that tic-tac-toe board in order to organize the information here in order to find both x and y. So 30, 60, 90 are the angles. 1 root 3, 2 are the side lengths of like a smaller scaled 30, 60, 90. And our picture is the new 30, 60, 90, a larger scaled version of the 1 root 3, 2. So in the first column, 30 degrees goes the side length across the 30, which if you draw an arrow, it would be the x. Across the 60, if you draw an arrow, would be the 11 root 3. And then across the 90 would be the y. So then I look at my chart and find the column vertical, which has only numbers. First column has a 1 and an x, so that fails. The third column has a 2 and a y, so that fails. So the middle column has just numbers. So you're asking yourself, if I start with root 3, what do I multiply it by? What do I scale it by in order to get an 11 root 3? So you could write your equation root 3 times some number or some scale factor. I use d instead of an s because s looks like a 5. D for dilation. Root 3 times some dilation is 11 root 3. Hopefully this is kind of easy to figure out what's missing between these two, just the 11. But if you had to solve for d, you would divide both sides by root 3. So your dilation is 11 root 3 over 3, and the root 3's cancel out. So the dilation here is just 11. So you're multiplying every column by 11. Your scale factor here is 11. So in order to find x, you look at the first column. It's just 1 times 11, so x is 11. And if you look at the third column, y is equal to 2 times 11, so y is 22.